And good morning, everyone. Thanks for joining me in this breakout session of the Automation Developer Days. Topic today is building automation for firewall policy provisioning. And my name is Fatih Ayvaz. I'm software architect in Cisco CX organization. And I will be your speaker today for the next half an hour. So in this security context, or in particularly in the firewall configuration, this journey for me started almost a year ago with a customer engagement. Their requirement was to implement this automation of the firewall policy configurations, and it was really a challenging project. Requirements were not really well defined. I mean, just like in any other automation project. And we were asked to do the turnkey solution, which is ending up in policy configuration changes on the firewalls, multi-vendor firewalls. And the input, the intent we will receive was very limited. So the challenge here is expectation from automation is to do all the groundwork, all the hard lifting, and end up in this successful provisioning. So that was the story, how we started this solution. With great support of definitely industry's best experts in network and firewall technology, we designed and built this solution together, and I have the privilege today to speak about it. Continuing with the customer scenario, last November, we also deployed this project in our second service provider in Middle East again. We positioned it, and the delivery has been going on under very high time pressure. And I'm glad to share that after having gotten the acceptance from the customer, this solution has been put into production a few weeks back. And it has already fulfilled more than 100 service requests on firewall in the past couple of weeks. So what I'm talking on today, whatever the content I'm presenting today is truly related to a real customer scenario, customer success with this proven track record of generating customer value. Agenda for today, again, not in a particular order, but I would like to cover the challenges, the problem, where the problem lies. And we will take a look at the solution design and the building blocks, the architecture. In fact, I will be spending very significant time today to really demonstrate the architectural pieces. So don't expect any low-level CLI or configurations or NSO configurations from my session, but focus is really on the architecture, how the design was built, and how it is really processing a certain flow to achieve the goal we want to have from the automation. And it is still going on, it's still under development, it's still under improvement. We keep on adding new features and new functionalities every single day. Because it's a live project right now, it's going on in multiple accounts, as I mentioned. So therefore, I would like to also have some moment to discuss on the limitations and the future work. What we are really short at, what we are planning to improve. And there will be a part for Q&A. So let's take a look at this set of questions, if today sound familiar to you. So to the security or the network teams, the problem for the access can come in very different ways. So this is how we say as the user intent or the user problem statement. So they can say, I cannot access to this server, as simple as that. Or if the client is knowledgeable on the network and has some idea how the network is, really designed and deployed, they can tell you, okay, I need an access on this firewall, or maybe there are multiple firewalls to access to a particular service. And then the statement is not really, helping you, because you also need to know what vendors and types of firewalls are involved, which teams are really controlling these firewalls. Can they configure them, and when they can do this? These are all the challenges we have when we are especially dealing with security teams, our dear security colleagues. So, as I tried to mention about the user intent, it can be represented as structured as this way. So the idea is allowing an access, what we also call as the whitelisting, from a particular source address to a particular destination address, where the target service is residing on. And sometimes you may want to have this access starting from today for 1 month period for a particular time bound. So this is the user intent, this statement, and we will be formulating this statement into request. Now let's look at the key challenges. So intent is given. We know what the intent is, what user wants, what the client wants, what their problem is via the access. The left-hand side yellow box represents our source. The gray one is representing our target service, the destination. And usually in large networks, in service providers today, the path traverses multiple organizations. And various firewalls may exist in the path from maybe various vendors. So the challenge here is the intent is given. We need to find the path from source to destination. Why? Because I would like to know where the firewalls exist, which firewalls are there. And when I find the firewalls, I'll apply my config changes. And challenge still continues. When you find the firewalls, you need to go and access the right team. The firewalls are being controlled by usually different teams. IT has firewalls, telco team has firewalls, other team has firewalls, and firewalls are really precious. They don't want you to touch or finger them. And when we are talking about multi-vendor firewalls from FortiGate, Palo Alto, Juniper, Cisco, then comes the challenge of technology and the skills. You need to find the right person with the right skills, who knows this technology, the language of the bugs, and who can help you with this. And challenges continues with the change management. Since it is firewall, applying any configuration is not easy. You need to get the agreement from the change management. You need to follow some approval process already established in the company. And there are implementation challenges, especially when you are trying to touch the firewalls. You need to know what needs to be done in case of an error, how the rollback can be applied, how can you apply the post checks, how can you know your intent is really achieved, etc. and etc. So these are our key challenges. So we talked about the intent, we discussed about the key challenges. Let's think about the key takeaways from this session. So the very first thing is, of course, the automate. So the power and the value of automation, especially if you are trying to addressing really complicated solution requirements, such as configure multi-vendor firewalls. Automation is the key. And automation is usually not always enough. When you deploy the automation, you want it to be presented to the user in a simplified way, using some portals, some user-friendly interfaces. You want it to be usable. You want it to be adopted. People will be using it. So those are the two key takeaways from this session. I hope it will satisfy. So we are talking about firewall policy intent automation. Things to consider. This is a typical network. Well, when I say typical network, it is for me a well-structured network. Why? Because devices are grouped under the DCs. So DC has a particular layered architecture. Again, this is not a DC session, but just to give an idea about how the access may happen. On the very left side, we have the source. On the very right side, we have the destination. And we are trying to give access from source to the destination. And my source may be connected to an ACI fabric through maybe some load balancer to a layer of firewalls, then DC gateway. Then after this access, maybe it will traverse through some MPLS network, some VRF overlays, or it will go to the internet and etc. So there will be some multiple clouds that will be staying in between for my access to the destination. So the intent then will be formulated and represented in some way that can help us for the provisioning. I know what my intent is. I would like to allow a particular protocol and access from a source, from a destination. Then in this example shown, I have some parameters. The green ones are the ones that are supplied by the user in my intent. So we know the source, destination, protocol, and port. But this is not enough. We need to know which firewall devices that we need to apply our policies on. And this is the job of automation, as you can see on the very right side column. And since we are all familiar with the NSO, we need to also know whether we will be using an existing policy or we will need to create a new policy on the firewall. I don't know how many of you have deployed firewall provisioning before. Can you just raise hands? Yeah, thanks. Good number of people. So the challenge here is, firewall configuration is not like the router configuration. It is making use of multiple objects, mostly reusable. And firewall people are usually really concerned about minimizing these resources, optimizing these resources. So if you want to create a new policy, you need to have a good reason of it. You need to really scan the existing policies. If they can be optimized or modified for your need, the expectation is to use them instead. So the policy name is following the discussion. Source interfaces, because this is a firewall. Packet is coming from some source interface. It's going out from some egress interface. I need to know these interfaces so I can apply my policies on them. So moving forward, this intent can also be represented in a more structured way like this. So it doesn't have to be from one source to one destination. Usually it comes with a set of sources, want to reach to a set of destinations, maybe a set of DNS servers, maybe a set of AAA servers, NTP servers, etc., you name them, on some set of particular ports. So I will keep this picture from time to time to refer back to my firewall policy intent. Now, what we need to consider in building the automation for that. How to identify the firewalls. I already talked about it. We need to find the path. And finding path is, I think, one of the key solution novelties from today, if you would like to remember, if not the others. And path from one source to one destination is one thing. Path from multiple sources to the multiple destinations is another thing. And we will also cover that. And we need to know the ingress and egress interfaces for the reason I just talked about. And whether to use an existing policy or create a new policy. And okay, so far we can understand and we can follow. All these things make sense. But when usually the policy, firewall policy requirement comes in, they really want to apply it so quickly. So they don't have the luxury for you to log into each and every device, go to the next hop, do the same, go to the next hop, do the same until you reach to the destination. It will take so long time. And why would we do this if we can find the same path in the software speed? And this is what I'm going to talk today. Okay, using the same network drawing, little bit more scenarios, just to make the picture a bit more scenario rich. I still have my source. My first destination I want to reach is connected to an ACI fabric. Okay, this is typical. Or I may want to reach to a destination 2 type, which is having a gateway directly on the firewall, not through the ACI. Or there can be another destination which is not inside my network. Maybe I would like to reach out to the Facebook. Or there could be another destination, destination 4, which is directly hosted on the same fabric that I'm connected to. So these are all different scenarios, and for each one of them, you need to find the path, The challenges are continuing. The things to consider in the automation are, these networks are usually multi-vendor, multi-function networks. It's composed of load balancers, fabrics, firewalls, as we talked about, some different routers, and etc. So you need to consider all of them while finding the path, and they can run multiple protocols. So when we talk about this, we usually try to distinguish the network devices into two. Some devices, we only want them to find the path. Okay, they are participating in the path. And some devices are only I'm interested in for the provisioning. So we call them the provisioning scope, which are the firewalls for now. I'm not doing provisioning on anything else. Okay, so this information is a good set, but I still need some user data that will help me in the automation, because my automation is tasked to find some things, right, derived from the user intent. And this data has to be fulfilled by the user. So I need a UI, which some admin privileged user can come in, do some mapping data. If a new network device is added to the network, they can modify and edit this and etc. This is an interesting one on considering the solution. Usually the organizations have the established process of how to apply firewall policies. What we refer as the communication matrix for the sake of conversation today. The communication matrix can involve many different fields that will help the firewall person to make the provisioning job. So here the standardization of the communication matrix will be also the job in our software project. The customer needs consultation, they need guidance from us. And in fact, all these fields may become very unnecessary. We are trying to minimize the communication matrix. And we would like to apply some rules onto this communication matrix within our automation job. And this communication matrix can be uploaded as a CSV file, which I will show you in the upcoming slides. Or they can be also edited on the UI, in the UI form. Last but not least, we need to consider about the user roles. In the firewall world, there is a requester who is filing the intent. There is some person who is approving this change management task. And there is a person who's deploying these changes onto the network. They have all different roles, and they need to interact with the system in some way. So the architecture will look like this. On the top side, we have a set of databases that we store these elements. What is really important for me to talk on today is this right-hand side for me, where we have the offline data sets. So this is what makes the solution work in software speed. Whenever I need to find a path, I don't need to log into the device hop by hop. I don't need to do CLI commands. I don't need to do iterative show commands and etc. But I will be using my offline data sets to compute my path. This offline data set has three types of tables. One is the subnets table, the other is the interfaces table, the third one is the routing information table, all extracted from the network devices. So we go implement some sort of a logic which will understand the language of Juniper, Cisco, ASR, ACI, F5 load balancer, Citrix, and etc. All these devices, we go and check them, we collect the data, and we store them here. Of course, the topside platform has a portal, which is an important piece of our session today, because we are talking about simplification, user friendliness. This portal will be also shown with some screenshots today. When we have this portal and the database sets, we also deploy some processes which will help us in the solution. And expectedly we have NSO as the underlying component, which will be in charge of doing the dry run and the commit changes onto the devices. And there we will use the firewall policy provisioning package. So these are my process stages. I receive the intent. I will apply my pre-checks. In my examples, it will be the blacklist rules. Then I will do the path finding. I will find the path from source to destination. Then I will provision. Then I will apply my post checks. In fact, the solution stages are as simple as this. Now let's take a look at the data sets. Here, an admin user logs into the portal that I just talked about on the platform, interacts with my system, and applies some mapping data, NOT table, ACR to PBR redirection table, and etc. Some details. On the parallel side, I will be having my automated scripts connecting to the network, collecting all this data that I just talked about, and storing them inside my offline datasets. So these are the datasets that needs to be ready for my solution. When this data is ready, let's see how the workflow will be represented. Requester, this is the role. I will be talking too much. Requester will be interacting with a workflow. What he does is filing the request data, which I referred as the communication matrix. This will trigger the workflow and notifies the approver. Approver will be interacting with the workflow. As soon as the approval happens, then the system will apply the pre-checks. It will compute the path interacting with these datasets. The path computation will be done. Path will be found. After the path is found, we know the firewalls. We do the provisioning process for dry run only. And this dry run is shown to the designer, which is the next level of person. This is just an example of workflow, by the way. These are all rendered by APIs. In any workflow, as soon as our APIs can be consumed, this can be possible. This is just an example. The designer approves it, and implementer will interact with our system again through the APIs. Now with the provisioning to commit down the changes. And after applying the post checks, our process will be done. Okay, this was the representation with a workflow. How about with a portal solution that we right now have with the second customer? Again, a linear workflow has been coded and implemented. It is not really using a workflow engine under the hood. We can, but we didn't use right now. There is a portal on the left-hand side where the requester uploads and submits. Pre-checks are applied, goes to the approver. Approver approves. Then the system will call some APIs. It will calculate the path. The dry run is generated. It will be made available for the next user, which is the implementer. Implementer checks that. If he or she is happy with the dry run result, they decide to commit. Roles and interactions. So the admin user is the one who will interact with the system to maintain the user maintained data that I just talked about. In this screenshot, I don't know how visible it is all about blacklist rules. In organizations, usually, they don't want to allow any particular source IP addresses to any particular destination IP addresses or any ports. So some ports are really banned. They don't want to allow anything ever for them. So these are kind of the blacklist rules that we can apply here. And this is done by the admin user in my case. Now the requester. Okay, I have the intent. I know what to do. When the requester logs in, as shown in the screen, he will be shown with these existing requests with some statuses. And this create request button will be the one that he will interact with. But the requester has a task, right? Important task. He is the one who is inputting the firewall policy intent. And firewall policy intent, in this case, has a particular CSV file format. It's a predefined format. The good thing here is about the simplification. So the customer is already using CSV files today. They already use it. So we just didn't really invent something new, but we took their existing CSV file format and we made our system recognize this file as shown. Of course, there are too many fields, but only those 4 fields for the sake of simplicity, I include them here. If you can provide such a CSV file, that's enough. That's enough for the communication matrix. And what the requester will do is, requester will upload the request using the upload button. This is the CSV file. Once the CSV file is uploaded, the user input form will be filled automatically. As soon as it is filled, you will also apply the pre-checks. So if they're all pass, it is good to go for submission. The requester can now submit. As soon as the submission is happening, there's a request ID generated by the system. Now, the next user in the workflow is notified, which is the approver. Approver has a view like this, similar to the requester, but they cannot do anything. They can just approve or reject. When the approve happens, we can go to the next user. But while going to the next user, what is happening in the backend is, since the approve happened, we automatically start the path computation. Therefore, when the implementer logs into the system, he or she will be ready with the view of calculated path and the generated try run. As you can see on the screen, for each and every row in the CSV file, the Excel file, I call them as rule. There's a rule ID. I don't know how it is readable. For a rule ID, I calculate two things, the path, and the path here is, in my example, involving 3 hops. As you can see in the paths table, the first row is the first hop, meaning that my source is connected to the ACI device on this particular context and VRF. My packets of this IP address are going into this ACI device on this particular ingress interface, going out from this egress interface. Similarly, the same path computation happens for the second hop. The second hop is, in fact, a firewall. Looks like after the ACI, I'm reaching out the firewall. This is the firewall device name. Similarly, my packets are coming in from a particular ingress interface, going out from a particular egress interface. And my path computation ends with another ACI device, which is the device where the destination is residing on. Path is found. There are a number of hops. Only one of them is firewall. Okay, I found the path. I found the firewall. I know where is the ingress interface. What is the egress interface? I know my source. I know my destination IP. Then I can apply my NSO package to change the configuration of the firewall. And the dry run result is shown. Again, for simplicity, I included a very small dry run here. If it involves multiple firewalls, we will show the dry run for each firewall as taken from the NSO. So this is the real value and the beauty of the solution, which makes it really differentiated from any other solution in the industry, in the market today. And then, implementer will just click on commit and the job is done. Since I talked about the path finding and path computation, I would like to spend maybe a couple of minutes on this, how it works. For a network engineer, if you have a network drawing like this, and if the intent is a connection from A to E, from red to the blue one, it's easy, you are the designer, you are the network person who deployed this network. Okay, these are the hops, these are the path, I know. All right. But how about software? How can software know it? In the software, in our solution, we will be consulting to these offline data sets. When a particular source and a particular destination is given, the first thing we do is find the hop facing the source, find hop facing the destination. We do it for a particular reason. Not all the time the destination will be in your network. Maybe it is on the internet. Maybe it is an unknown destination. Maybe the hop cannot be found. So doing this task in the first place will help you understand which scenario you are in, which use case you are working on. Once you know the hop facing the source, hop facing the destination, iteratively you perform these queries against these databases and you find all the path. If the last path matches what you found for the destination, voila, the path is found, path is verified. And this is kind of how the path finding works. And yeah, I'm happy to have question and answers. If time permits, I can maybe display some limitations and future work, but more importantly, I'm open for questions right now.
Hi, Fateh.
Hi, Lenin.
So regarding the path finding, you just mentioned that you recursively identify the hops, and then eventually, if you find it, that that's your path. What if you find multiple paths, how do you decide on this? Are you like configuring the policy on all of those, or how do you do it?
It's a very nice question, Lenin. Thank you. Right now, the solution is assuming only one path. So this is currently the agreement with the networking and firewall experts. But this is a very valid question. We receive it time to time. Solution is not really limiting us to find multiple paths, but the current design of the data sets today only allows one path. So it is a future work for us. In the next versions or the iterations, we want to include them. For us, it is not really a big deal. If you find multiple paths, still what we are interested in is the identification of the firewalls. As long as we find the right firewalls and the right parameters, ingress, egress interfaces, we can apply the policy. But this is something to be done. But currently, this one I'm presenting today supports only one path. Thanks for the question.
We have one more down there.
Yeah, sort of a design philosophy question. What was the reasoning for all of the heavy path computation up above NSO? I mean, that is sort of possible to solve in the orchestrator, isn't it?
Thanks for the question as well. Just one clarification is pathfinding is happening above the NSO level on another platform. It's not on the NSO level. And for the pathfinding process itself, it is making use of certain data sets that I talked about. And actually, you are raising a really good point. As a future work, one of the tasks is to investigate if we can move these data sets also into the CDB. Maybe we will run the pathfinding from the NSO then. But today, it is kind of done at the upper level. We can call it the orchestration level. It will not be incorrect. But today, this is what's been happening now in the solution. Does that answer your question?
Well, not really, but it contributes to it. Thanks.
Well, we don't have a true orchestrator right now. Maybe this is the challenging bit. So, and also is the... Go ahead, please.
Yeah, so like out of band changes, and that's why you need to pull data up and react to it so things aren't, or...
Yeah, these out-of-band changes will all be recognized in these offline data sets. If we move to CDB, we will be in a more safe and secure place. But right now, out-of-band changes will not be truly reflected because I didn't mention, but this data collection is done periodically, maybe at 6 a.m. every day. So if there are changes out of the band through the day, they will not be truly reflected to my data sets. This is one limitation. I have to agree with that. But if you are not frequently touching the network, I mean changing the routing decisions, this solution works. Again, as I told you, it's already under production in two customers.
All right, thanks.
Thank you for the question.
Hello, Fatih.
Hi, Fatih.
Do you just maintain one whitelist or blacklist, or do you have it per zone? Because in quite a lot of organizations, you have different security policies and you want to treat protocols differently depending on whether it's going external from their network or internal within different zones. So do you have that capability?
Yeah, there are zone recognition. There are some different mechanisms that we recognize the configurations from. This is also something to be improved, but yes, we are aware of the zone. Actually, this is also related to the technology, how the zone is being, making sense to the firewall language. So, particularly, I showed the FortiGate. It could be done on the Palo Alto and the Juniper. So, this zone recognition is part of our task. It's covered.
Just one contribution to the answering this question previously, Fatih, if you allow me. Why we are not doing this from NSO. I believe for the customer that we have now, even the customer himself is not allowing us to control all these devices from NSO directly, right? So for cost perspective reasons sometimes, but we don't have access to all of these devices from NSO. It's not controlled as of now. That's why we are using another orchestrator that can have direct access to these devices to collect this information, because we are traversing different domains and we don't have NSO managing all of these domains as of now.
It is coming down to, thanks Amr for highlighting this. I talked about routing scope and provisioning scope. That's another good reason. But again, there is nothing stopping you to buy nets and having them in our NSO recognizing different devices. That can be done. Yeah, sure.
Yeah, I had a question here. So have you considered applying automatic testing of these rules once they are deployed? Since I'm from Axidian, it's an interesting topic. If you deploy test agents, right, to see if you have TCP connectivity or UDP on this port is blocked or something like that.
I believe timing is perfect for this question. Right now we are considering the post-check part. On the post-check part we have some ideas. And yes, we will consider some sort of testing there, definitely. We just didn't decide yet. It's part of consideration right now.
Okay, hi Fatih. What are the most security vulnerable parts of this approach?
Vulnerable part?
Yes.
Wow, I'm not prepared for this question. Thanks for that. Vulnerable part, maybe my comment is, I think the firewall configuration itself, any single incorrect line will, blow off everything. So I believe that's the part, because through the acceptance period, with the customer took some time. To build this trust, we had to do many testing cycles, and every time we found the configuration is not 100% correct. Of course, this is not the automation's problem. This is the problem of how we do communicate and how we get the requirements. Because as you know, the NSO, if you instruct it very well, what the template will look like, it will do the job. But this part has been kind of the vulnerable part for us for some while. And this is the part which is really affecting the entire network. So this is what I would say about it.
One question from my side. How do you compute whether there's an existing policy on the route, on the firewalls, before you apply a new one? And the ordering process, can you talk to that a bit?
Yeah, we are just making use of NSO. Yeah, we know from the NSO what are the existing policies. We develop some certain logic for that. By the way, thanks for the question. That's very good on the optimization part. Right now, we have a logic that, using these triplets in my intent, sources, destinations, and ports. If among these three, two are already covered in an existing policy, we go and modify for the third one. Well, it is very difficult to explain like this, but if they don't match this logic, then we do create a new policy. So this is the current behavior right now. But we do get this information from NSO. We read the policy. What are the sources? What are the destinations? What are the ports involved in this policy? If they do match the criteria I just talked about, then it will become modifiable. So I can make use of this existing policy. If it doesn't match this criteria I just talked about, we do a modify. I believe this is also a logic that needs improvement, but this is currently what we do today, just to answer your question.
Okay. No more questions? You have one? Good.
Hey, Rene.
Hi, Fatih. Thank you. When you're mainly like a FortiGate, in FortiGate, when you're inserting a new firewall policy, you can say insert after, insert before some other firewall right on the optimization side as well. And one issue that I have in my customer, I don't know if you have that, and if you have, I just want to know how you are addressing this problem. It would be when you do insert before, you're just sending a new firewall policy, but it's changing all the orders of the other firewall policies, making your NSO being out of sync. I don't know if you have that issue.
We have an ongoing attack case right now around this issue. That's what I will say, but how it is relevant, maybe it was a small detail here. In this view, so one challenge was, okay, it's very poor, sorry for that, but in the dry run, there is a number, edit some number, for example. This number has to be calculated. For example, if the FortiGate is configured for 100 different rules, The one you are configuring has to be 101. If you just use the network engineer's style, just add a new policy, then it will become out of sync. So we had to calculate this. But this problem we covered like this. We have now other issues that will fall FortiGate into, sync issues. We are working on them. But that's an area which keeps us busy. No worries.
One more question.
Michael, please.
Sorry. So I've been dealing with another project with ACLs being applied to like iOS XE XR devices. How do you do the smart insertion of your firewall rules on those devices?
Okay, thanks, Michael, for the question as well. First of all, this is the one I talked about. Is not really about reordering like you just described for the ACL world. Again, referring to the same example, if you are creating a new policy, you just follow a particular policy index order on the firewall. But for the firewall, how the processing happens in which order is, I don't know that domain. But what we have been asked is, just if you need to create a new policy, you just need to follow the order. So what I know is it's not like the ACL style. But if there are conflicting policies, I don't know how it's been treated on the firewall. I didn't work on this part. We just tasked to provision based on the rules. But I will try to engage with the firewall expert that we work on. I think he has a better answer for you.
So follow-up question. So you don't deal with like ACLs on routers?
Not right now. The one I showed you is the FortiGate. I think we have Palo Alto and Juniper as well, and some Cisco. Not the ASA. No problem. Thanks for the question.
All right. So if you have more questions, continue the discussions during the break. So
I will be around for the next 1 or 2 hours. Sorry to cut you up, Niklas. I'm happy to hear all the questions. And if you would like to have me to run some demo for you using the lab environment, I can do that. For the sake of this presentation, I just included the screen. But we can continue discussion after.
Yeah. Okay.
Thanks.
Thank you.
Thank you.